Hey guys, so today we're going to talk about the eccentricity of a planet's orbit. So let's talk about a few vocabulary words. The first is elliptical. Elliptical is a term we use to describe the shape of a celestial object, and in this case, we're talking about the orbit of a planet. So elliptical means more of an oval shape rather than a completely circular shape. So when we say the orbit of a planet is more elliptical, we're saying that the orbit that the planet is going around the sun, the shape that it's creating, is more of an oval shape rather than a circular shape. And then we have eccentricity. When we talk about the eccentricity of a planet's orbit, we're seeing how close to oval, elliptical, or circular the shape of the planet's orbit is. Okay, so it's more eccentricity is more of a rating on how oval or how circular the planet's orbit is, and elliptical is more of a shape. So in this case, a more oval shape. Okay, how oval? The eccentricity tells you how oval versus how circular the shape of the um planet's orbit is. So we said eccentricity is more of a range, right? It tells you how oval or how circular the how elliptical the shape of a planet's orbit is. So the closer to zero that your number for eccentricity is, the more circular the planet's orbit is, kind of like this red. And the closer to one your number for eccentricity is, the more oval or elliptical the planet's orbit is. Now, please don't use the word oval. It's just to help you understand the shape. We normally go with the term elliptical instead of oval when we're talking about celestial objects. And also, eccentricity is always a number between 0 and 1. It's never less than 0 and it's never greater than 1. So it's always a decimal, kind of like you see over here. And once again, the closer to 1 it is, kind of like Mercury's orbit, the more oval its shape or elliptical shape the orbit is, and the closer to 0 it is, kind of like Venus. Venus's orbit is more circular. And also notice that eccentricity actually has no units. Never use units for eccentricity. It's just like kind of a range, a scale that we're using. So it's just a number. Always only write a number, no units needed. So let's look at a simulation for eccentricity. So this is how normally a planet revolves around the sun. And notice that the sun is not completely in the center, it's kind of on the side, right? So what we normally do is wherever the sun is, we create another area, or we mark another area, and we call this a focus, okay? So the sun is one of our focus, and this is also another focus. These will help us measure how eccentric or elliptical our orbit is. Okay, so we have our sun. Our sun is always one of the focus or foci, and we also have an imaginary empty one just to see, and it will help us figure out how oval it is. Now, the planet is going around, and this scale right here tells me or shows me what the orbit will look like as I increase the eccentricity of orbit versus decrease it. So as I decrease the eccentricity, notice that my empty imaginary focus is getting closer to my other focus, which is the sun, kind of like this. Also notice that that's happening. My orbit is becoming more circular as my eccentricity is going closer to 0. And my when my eccentricity is fully 0, notice that my focus is right on top of the sun. That's why we're creating an imaginary focus, because it helps us figure out how elliptical the shape of my orbit is, whether it's completely circular or more elliptical or oval shape, okay? And notice the more oval or elliptical the shape is, the farther away my foci are. My sun is my focus, and this is my empty one. The farther away they are, the more oval or elliptical my shape is, and the closer they are, the more circular my shape is. Okay, and this is actually Mercury's orbit. Let me clear again and show you. Um, but what about Venus? This is Venus's orbit. It has an eccentricity of 0.07, and then Earth's orbit has an eccentricity of 0.0717. It's a little more elliptical. Then we can look at Jupiter. It's a little more elliptical. And then we can look at Neptune, and it's slightly more elliptical. Most planets orbit aren't completely elliptical, but a lot of them can range from more circular to elliptical. Okay. So here are some notes for you. There are two things that we need to look for when we're calculating the eccentricity of a planet to figure out how elliptical or circular the orbit of a planet is. And that is the foci, or the two focus that we're looking at. One focus is always the sun, whether the sun is on this side or this side, and one is an imaginary focus that's about the same distance as the sun from the sides of the circle. Okay, so two foci always. And then we also use the distance from one side of the orbit to the other that goes through the foci to measure the eccentricity. So if you go on your reference table, page 1, you'll see the equation right here. The equation for eccentricity is distance between foci divided by length of major axis. So distance between foci are these, your sun and the imaginary dot. If you take the distance and put it on the top numerator, you can just plug it in. And then the major axis is actually an imaginary line that goes from one side of the orbit to the other side of the orbit through the foci, as you can see, not higher or lower, through it. And if we measure this distance, which is the major axis from A to B, and we plug it into the denominator, it can give us the eccentricity. And remember, one means it's more of an oval, and or a line even. Basically very, very oval, and 0 means circular. Okay. And once again, one focus is always the sun, and the more elliptical it is, the more oval it is. The greater the distance between the foci, the sun and the imaginary dot, the closer the eccentricity is to 1, and the more elliptical it is, the shape. And the smaller the distance between the foci, the more circular the eccentricity or is, and it's closer to 0. And this kind of gives you a picture of it. 0 is circular, and the closer to 1 you're getting, the more elliptical it is. And this is the equation we're using. Remember, there are no units for eccentricity.